This is the statistics. We are going to the final review for the chapter 7. Formula z-score or standard score. Those three formula are in chapter 6. Z-score formula, central limit theorem. If n is not equal 1, standard deviation divided by square root of n, and the z-score for the sample mean, x bar. And the binomial distribution mean formula, mean equal n times p, standard deviation square root of npq. Those three for is in chapter 6. Normal distribution, and we talk about, and use the normal distribution to approximate the binomial distribution. That's in chapter 6. Today, chapter 7, we are going to learn is a confidence interval. First one is a confidence interval for the population mean. When sigma is a standard deviation is a given, and you will use z-score. Use z-score. And the sample size for the mean is n equal z times standard deviation over e. E we call margin error. Margin error. Margin error. Which is the from the mean, from the sample mean, to the population mean, the difference. We call margin error. E is the margin of error. It's over here, which is the difference between sample mean and the population mean. Confidence, that's the if a sigma standard deviation unknown, and given sample standard deviation, and use t-score. If a sigma is known, population standard deviation is known, use z-score. If unknown, and the sample standard deviation and the population standard deviation sigma unknown, and use t-score. That's the two are for the mean, confidence interval for mean, and n is sample size for mean. And next is proportion. Confidence interval for proportion is always use z-score. Is p hat is sample proportion minus how many standard deviation from the mean, from proportion mean, from the sample from population proportion, and times standard deviation for the proportion is the square root of pq over n. And p hat is x over n, sample proportion. Q hat is 1 minus p hat. P hat is the sample proportion. So this is the confidence interval for proportion. And next is a proportion sample size formula. N equal p hat q hat z alpha over 2 over e. E is also margin error and square. Next is a confidence interval for variance. Variance is n minus 1 s squared. S is standard deviation of sample over chi-square right. And the other side is chi-square left. That's a confidence interval for variance. And this take square root, and you will confidence interval for standard deviation. So we have a confidence interval for the mean, sigma known and sigma unknown. confidence interval for the mean, and confidence interval for the proportion, confidence interval for variance and standard deviations, and sample size for the mean, sample size for the proportion. Those are the formula used in chapter 7. Next one, first question. A recent study of 700 internet users. So given condition, n equals 700 internet users, and in Europe, found that 27% of internet users were women. So this is a proportion, p hat, sample proportion. Sample is p hat equal 27% converted to decimal 0.27 were women. And what is the 80% confidence interval? So 80% confidence interval asked for of the true proportion for the p, true proportion of women in Europe who use the internet. So this is a find out the confidence interval for proportion, true proportion. So then we will use this formula. Now, given condition here, Q hat is 1 minus P hat, 1 minus P hat, and P hat is 0.27. 1 minus 0.27, Q hat is 0.73. Now then you use the proportion, confidence interval for the proportion, this one. Confidence interval for proportion, this formula to do. So will be P greater than P hat minus how many standard deviation away from mean, Z score times square root of this is the standard deviation. Z score is number of standard deviation and times standard deviation. The other side is a plus. This one is a standard deviation. This is a sample standard deviation. S for proportion equals square root of P hat Q hat over N. That's the standard deviation. S for the sample standard deviation. And the confidence interval 80%. For proportion, we always use Z score. 80% confidence interval. So you can use this table. This is a T distribution table. T distribution table. 80% confidence. So you're looking for 80%. 80% confidence. And then you go to 80% confidence. And you go down to the bottom. To the bottom. To the bottom is a Z score. Z score. Z is 1.282. So for the 80% confidence interval, Z alpha over 2 is 1.282. Is use this T distribution. 80% confidence interval. Then you go down to the bottom row. That is a Z score. Z equal 1.282. That's a Z score. And P hat is 0.27 minus Z score is 1.282 times square root of P hat 0.27. Q hat is 1 minus 0.27 is 0.73 over N. N is 700. And less than proportion, population proportion, less P, less than P hat, and change this minus to plus. And the others are same as the left side. on left side is minus, on right side is a plus. Then use calculator, you can figure out its proportion will be between 24.85% and 29.15%. That's a true population proportion. Confidence interval, 80% confidence interval. The next one, find out the sample size for proportion. A federal report indicated that 29%, which is a p-hat, equals 0.29, of children aged 2 to 5 years had a good diet. Ask you how large a sample. So looking for n equal how much is needed to estimate the true proportion of children with good diet. We think 4%. 4% is margin error. E equals 0.04. 4% is 0.04 with a 95% confidence. So 95% confidence. Those given condition. So figure out Q hat. Q hat is 1 minus P hat. 1 minus P hat is 0.29 and get 0.71. So 95% confidence, Z alpha over 2 is what? So use the this t-distribution table. 95% confidence here. Confidence interval, 95%. And go down to the bottom row, which is the Z-score. Go down to the bottom row. This is 1.96 Z-score. Z-score equal 1.96. 1.96 on the top. 95%. Go down. Go down. It's a 1.96. That's the Z-score. So here Z alpha over 2 is 1.96. And plug into this formula. This formula is also on your formula sheet. This sample proportion formula, sample size, n equal p hat q hat z over e quantity square formula. So p hat is 0.29, q hat is 1 minus p hat is 0.71 times z score is 1.96 over margin error is 0.04. And this 1.96 divided by 0.04 is a 49 and square and times it and get 494.3659. Always round up. Even this is 3. It's not more than 5. You still round up. Get 495. So we need to do survey for 495 children. Then that's what we call sample size. Question 3. A study of 36, so n equals 36 apple trees, show that the average number of apples per tree was 610. So it's X bar sample. 36 is a sample. So this is a sample mean. 610 is a sample mean. The average number of apples per tree. Each tree have 610 apples if you average. The standard deviation of population, sigma, is 90. 90 apples. That's the standard deviation. And find the 90% confidence interval for the mean number of apples per tree for all trees. So find out the population mean. 90% confidence interval. For 90% confidence interval, since this sigma is given, standard deviation of proportion is given, so use Z-score. So use this mean confidence interval for the mean formula, here Z-score. So Z score is the 90% confidence. You look at the confidence interval, 90%, and go down to the bottom row. That's the Z score. Z score 1.645. So Z alpha over 2 equal 1.645. Then plug in formula. X bar sample mean is 610 minus Z alpha over 2 is 1.645 times standard deviation sigma 90 over square root of n 36. This minus on left side. The right side is a plus. That's a confidence interval. So it's 90 over 36 take square root is 6. 90 divided by 6 is 15. So use calculator figure out. So the population mean average is 585.325 apples between 585.325 apples and 634.675 apples is the true population mean is between the two number of apples. Next one, question 4. A healthcare professional wishes to estimate the birth weights of infants. How large? So figure out n, how large of a sample must be obtained if she desires to be 98% confidence. So 98% confidence that the true mean is within 2 ounces. So margin error is 2 ounces. E is 2 ounces of the sample mean. The true mean is within 2 ounces of the sample mean. So the margin error is difference between true mean and the sample mean. That's what we call margin error. Assume the population standard deviation. So assume sigma equal 9. Population standard deviation is 9 ounces. So this is use the mean sample size formula. So mean sample size formula is n equals Z times sigma over E squared. So first of all, 98% confidence and figure out the Z score. So 98% confidence and use this T distribution table. Confidence interval 98%. Then you go down to the bottom, the last row, which is a Z score. This is a Z score. Z equal 2.326. Z equal 2.326. And plug it in. Times standard deviation 9 over margin error 2. And square it. Get 109.558089. Always round up. Add 1. Get 110. 110 sample size. Question 5. Find 90% confidence interval. So this question given 90% confidence interval for the variance. So looking for variance of the heights of maple trees. If a sample of 20 trees, so n equal 20 trees, has a standard deviation, so it's S, because 20 trees, standard deviation is sample, so it's S equals 13.45. Assume the population is normally distributed. So this, we will use the chi-square and the confidence interval for the variance. Variance is sigma square. This is population variance is between n-1 is degree of freedom, sample variance over chi-square right. And then the other side is divided by chi-square left. So here, because we use the chi-square table, so chi-square table need the degree of freedom. So n equal 20, degree of freedom is n-1, it's 19. From this, and looking for 90% confidence interval. So we first of all, we draw this chi-square. Chi-square, because square is positive, minimum is 0. So it's non-negative. So this here is 0. And this is a chi-square curve. And then you go 90% confidence. So between this two chi-square left and chi-square right, this is a 90% confidence, 0.90. So 1 minus 0.90 got 0.10 is the two tail, the two side, divided by 2. So each side 0.05, the other side also 0.05. And since chi-square, we are using the chi-square table. When we're using chi-square table, we have to look at alpha is here and find out chi-square. So it's to the right of chi-square using this area. So we have to figure out this area, 0.05, and this is chi-square right. Figure out with degree of freedom 19. So this area is 0.05 to the right of this chi-square. This area is 0.05, and the chi-square is equal what? With degree of freedom 19. So we go this chi-square distribution, degree freedom, it's a 19. Degree freedom, it's a 19. The area alpha, 0.05. Alpha. Area is to the right of chi-square. Is 0.05. Degree of freedom, it's a 19. Intersection is 30.144. That's chi-square right. 30.144. That's chi-square right. Chi-square left. Since the table is figure out is alpha is this area. This area is 0.90 is between and 0.05. So to the left, total is 0.95. So to the left of this chi-square, total area is 0.90 at 0.05. Total area is 0.95. And to the left, and figure out chi-square. So 0.95. So you look at this table. Degree of freedom is 19. 19. 0.95. 0.95. And go this. Get 10.117. So that's chi-square left is 10.117. Then you plug into this confidence interval for variance formula. N is 20 minus 1, degree of freedom, n minus 1, 19, times sample variance S square, which is S is 13.4 square, over chi-square right, 30.144. Less than the population variance sigma square, less than 20 minus 1, degree freedom 19, S 13.4 square over chi-square left is 10.117. Plug in. And use calculator, you will figure out this variance, because here one confidence interval for the variance. So it's a sigma square between 113.178 and 337.2185. the question 6. 9 squirrels, so n equal 9, that's given, were found to have an average weight of 10.5 ounces, so sample mean x bar, because for 9 squirrels, figure out average 10.5 ounce, with a sample standard deviation, so s equals 0.9, is 0.9 pounds. Ounce. Find 99% confidence interval. So looking for 99% confidence interval of the true mean weight. So assume the population is normal distributed. So this is S sample standard deviation, sigma unknown. So we will use t-score and use t-score. So 99% confidence degree of freedom is 9 minus 1, it's 8. The t-score is what? So we have to look at the t-distribution. 99% confidence here. 99% confidence. Degree of freedom is 8. Degree of freedom is 8. 9 minus 1 is 8. So degree of freedom here is 8. 99% confidence is this. 99% confidence. Degree of freedom is 8. Intersection 3.355. 3.355, that's a t-score. And plug into this for the mean, confidence interval for the mean. If sigma unknown, use t-score. So sample mean x bar is 10.5 minus t is 3.355 times s is 0.9 over square root of n. N is 9. And less than population mean, less than the other side is this minus change to plus on its right side. So we got 0.9 over 3, got 0.3. And use calculator to figure out. So the mean is 9.4935. True population mean is between 9.4935 ounces and 11.5065 ounces. Next one, Chapter 8, review. Chapter 8 review, it's we will talk about the hypothesis testing. For Chapter 8 review, hypothesis testing. We will use, again, we will use the z-test. Z-test for the mean. This is a sample test score. Z-test. X sample mean minus population mean over standard deviation over square root of n. This is for sample mean. T-test for the mean is x bar minus mean. Sigma unknown, use S sample standard deviation over square root of n. Degree of freedom is a minus 1. And the z-test for proportion is this, p hat sample proportion, p hat minus population proportion over square root of p times q over n. This is a standard deviation for the proportion. And use chi-square test for variance, and the standard deviation is chi-square equals n minus 1 degree of freedom times the ratio between sample variance and the population variance. Degree of freedom is n minus 1. So we have a z-test, t-test for the mean. If a sigma known, use z-test. If sigma unknown, given sample standard deviation S, use t-test. And the proportion is always use z-test. And the chi-square test is for the variance and the standard deviation. And also we will use the 5 steps for hypothesis testing. First step, state the hypothesis and identify the claim, which is null hypothesis H0, and the H1 alternate hypothesis. Second one, find the critical values like Z, like T, critical values. The third one, calculate the test value. Those formula is going to calculate the test value. And the fourth, decide whether to reject or not reject. Either reject null hypothesis H0 or fail to reject H0 decided. The fifth, summarize the results. To receive full credit, or work should be written as shown in class. Include all the 5 steps in hypothesis testing in your solutions. First question. First question, Dr. Christina Carterman, a nutritionist, claimed that the average number of calories in a serving of popcorn is less than 74. So this is a claim. Is less than 74. When you do the hypothesis testing, always you have to set up the H0 if it equal or greater than or equal, less than or equal for the null hypothesis H0. If not equal, greater than, less than, is go for H1, alternate hypothesis. So for this one is less than 74. So you put population mean average number, means population mean less than 74, which is go for H1, And this is the claim, indicate this claim. So H0 is going to be equal for equal. So null hypothesis H0 is mean equals 74. So given here, standard deviation, which is a population standard deviation, is 8. So sigma equal 8. A sample of 49, so n equal 49 servings of popcorn was